Hello students, welcome to my YouTube channel Scopeiit. Today we will discuss about the topic lock-based protocol. So what do you mean by lock? A lock is a mechanism that is used to restrict the access to the data item by the transaction. What do you mean by this? This means suppose if you acquire a lock on any data item, no other transaction can access it. Okay. So see, when a transaction hold a lock on a data item, the other transaction are blocked from accessing it in a way that could cause the confliction. Okay, so if you are using lock, that means there no confliction will occur. Now what is the need of locking? So we are using locking to avoid anomalies like lost update anomaly, dirty read means reading the same data after some period of time. So even dirty read should not allow. Then non-repeatable read. Okay, so these are the points. Because of that we need locking. Even to maintain the acid property. Now what do you mean by acid property? Acid means atomicity, consistency, isolation and durability. So here most probably we are using locking for isolation. Okay. Next, even it is used to synchronize the concurrent transaction. Concurrent transaction, that means if more than one transaction we are executing at a time, then we should apply locking to some data items so that confliction should not occur. So these are the three reasons. Because of that we are using locking protocols. Okay. Now types of lock. So there are basically two types of lock. One is your shared lock, another one is your exclusive lock. Shared lock means we can only perform read operational. Okay, so what do you mean by shared lock? Shared lock, that means if any data item are having shared lock, that means it can only perform read operation on that data item. Okay, similarly in exclusive lock. So in exclusive lock, what happen? In exclusive lock, if any data item is having exclusive lock, that means it can read and write both. So in shared lock, it can only read the data, whereas in exclusive lock, it can perform read and write both the operation. So as it can only read, that means multiple transactions can hold a shared lock simultaneously. Okay, so as I explained in my last video, what are the confliction? Read, no confliction. Suppose if I am reading anything, at the same time others are reading, no issues, right? But if one person is reading, another one is writing, confliction will occur. Similarly, one is writing, another one is reading, confliction will occur. Similarly, write. So these are the three conflictions. So see, here shared lock, we can only read the data. So if one transaction, that means one transaction is having shared lock on any data item, okay, the same data item can be locked by other transaction if they want only shared lock. Understood? Because read, no confliction. But exclusively we can perform read and write both. So because of that, only one transaction can hold at a time, not more than one. So see, here I have drawn one small diagram. If you will remember it, it will be easy for you. Suppose if you are having shared lock, can we apply a shared lock? Yes. Suppose I am having a shared lock any data item, can I give exclusive lock on that? No. Because one can read, another one can write. One is having exclusive lock. Is shared lock allowed? No. One is having exclusive lock. Is another exclusive lock allowed? No. Understood? So this diagram will help you. Only shared to shared is possible. Other than that, all the this lock will create the confliction. So I hope it's clear what is lock and types of lock. Next, we'll discuss about some lock-based protocol. So two-phase locking protocol, that is known as 2PL. Okay. Now why it is known as two-phase locking protocol? Because in 2PL we are having two phase. So see, one is your growing phase, another one is your shrinking phase. Okay. So growing phase and shrinking phase. Now what do you mean by growing phase? Growing phase means acquiring all the lock. Similarly, shrinking phase means releasing all the lock. So see, transaction can acquire the lock either shared or exclusive, and no lock is released in this phase. Growing phase means we can only acquire the lock. We can only take the lock. We cannot release any lock. Then shrinking phase, once the transaction commit or abort, it start releasing all the lock. So that means no new lock are acquired in this phase. So growing phase, in short, you should remember growing phase means acquiring the lock. And what do you mean by shrinking phase? Shrinking phase means releasing the lock. And there is one point after that we cannot take any lock. After that we will only release the lock. This point is known as lock point. So what do you mean by lock point? It is a point till that time the transaction will acquire all the lock, and once it reaches to the lock point, after that it will only release. Okay, so now in exam they can ask a numerical based on 2PL. They'll give you some transaction, okay, and they'll ask you check whether it is 2PL or no. So how to identify whether it is 2PL? So you have to check that it should be in growing and shrinking phase. That means if you have acquired any lock, okay, that is fine. So once if you have released any lock, once if you have unlock any data item, after that you cannot lock. That is what the concept of growing and shrinking phase, or you can say 2PL. Next we'll discuss about types of 2PL. So see, there are three types of 2PL. One is strict 2PL, another one rigorous 2PL, third one conservative 2PL. Now what do you mean by strict 2PL? So the strict 2PL locking protocol, all exclusive lock are held until the transaction commit or abort, but the shared lock can unlock before commit. So now what do you mean by strict 2PL? Strict 2PL means actually in all these 2PLs, the rule is either shared lock or exclusive lock that should be unlocked after commit only, but strict 2PL is having one advantage that it can unlock shared lock before commit. Exclusive though you have to unlock after commit only, but shared lock can be unlocked before commit only in strict 2PL. I'll explain with example. So this is the example of your strict 2PL. Okay, this is the example of your strict 2PL. So here you see, X lock means exclusive lock on A, then it performs some read operation, then A is equals to A plus 50, they have added 50 to A, then they have returned the value of A. After this, they have taken shared lock on B data item, then B is equals to B minus 20, and they have returned B. Now, you can see unlock. So, which lock they have unlocked? Shared lock. So, in strict 2PL, shared lock can be unlocked before commit. But, see, unlock of A, exclusive lock. Exclusive lock we have to unlock after commit only. Similarly, what is rigorous 2PL? So see, the transaction cannot release any lock, either shared or exclusive, before commit. Okay, so rigorous is following that thing. That see, X of lock, read of A is equals to A plus 50, write of A, S lock. See, this is your exclusive lock. They have unlocked after commit. Even shared lock also after commit. So, rigorous 2PL says that either it is shared lock or exclusive lock, it should be unlocked after commit only. You cannot do it before. Okay, that is only possible in strict 2PL, and that also only shared lock, not exclusive. That is the main difference between strict 2PL and rigorous 2PL. Okay. Other than that, these are very important points for GATE or UGC NET. This is the theory question direct they will ask. So see, in strict 2PL, if one transaction roll back, then other transactions should also have a rollback. So the transactions are dependent on each other. So as you know, if one transaction is dependent on each other, okay, so that means you can say it is having a cascading schedule. Cascading schedule, that means one transaction, okay, one transaction will affect the other transaction. Okay, so if one transaction fails, all the remaining transactions will fail together. Okay, so remember, strict 2PL is suffering from cascading schedule. That means in strict 2PL, cascading schedule can occur. Now, in rigorous 2PL, see, serializability. So rigorous 2PL, that means serializability is ensured, but deadlock can occur. So see, deadlock is not guaranteed. So remember, in rigorous 2PL, deadlock can occur. Deadlock is not guaranteed. It's not a deadlock free. Okay. Next, the third one, conservative 2PL. What is conservative 2PL? So the transaction must lock all the data item it requires in the transaction before the transaction begins. So, if any of the data item are not available for locking before the execution of the lock, then no data item are locked. Then the read and write data item need to be known before the transaction begins. This is not possible. Normally we can say, right? And okay, I'll explain this later. Before that, I'll tell you what is this. Okay, so conservative 2PL, in short, remember that whatever lock you want, take it in the beginning. Okay, whatever lock you want, take it in the beginning. What do you mean by that? That means, see, exclusive lock on A, they have taken shared lock on A. Once if you start the transaction, after that you cannot lock. Like see, this both you cannot say it is a conservative tuple. Why? Because see, they have performed the lock on data item A, after that they are performing some operation. After that again they are taking the next lock, which is not allowed in conservative. Conservative means we should acquire all the locks in the beginning only. So once if you start any transaction, either read, write, so once you start any transaction, after that you cannot lock anything. That is the concept of conservative tuple. So because of that, remember this conservative tuple is deadlock free. This is very important keyword. You should make a note of it. Okay. So conservative tuple, that is deadlock free. Even conservative tuple does not ensure a strict schedule. Okay, so strict, that means that is you can say sequential form. Okay, so it even does not ensure the strict schedule. So I hope it's clear. These are the three types of tuple, and it comes under tuple. That means it is a type of log based protocol. Next topic is timestamp ordering protocol. Now, what do you mean by timestamp ordering protocol? So basically, it ensures serializability. This is also the important keyword you should remember. Timestamp ordering protocol that ensures serializability. Even 2PL also ensures serializability. Okay. So here, by ordering all the conflicting operation according to their timestamp, and each transaction T is assigned a using timestamp, unique timestamp TS of T when it enters the system. That means a timestamp can be implemented in two ways. One, directly assign the current value of the clock to the transaction, or you can say the data item, and attach the value of logical counter that keeps incrementing as new timestamps are required. So in short, I'll tell you what is timestamp ordering protocol. So see, timestamp ordering protocol, it will give unique value. Okay, it will assign a unique value to every transaction. That means I can say, for example, first of all, transaction T1 comes. Okay, so they will give the value of transaction T1 as 100. After some time, if transaction T2 will come, so it will give the value 200. Understood? That means the transaction comes after will get larger value. That is what the concept of timestamp ordering protocol. So the transaction who will come first, that is the older transaction, and the transaction who will come later, that is the younger transaction. Understood? So that is what the main point. So here, transaction that comes after will get the larger value. Now, for example, suppose one more transaction T3 comes, then what value it will get? It will get the value more than 200. So maybe it can get 300. It should be more than 200. That's what the concept is. Okay. Then next, this timestamp of the data item can be of the following two types. So there are two types possible. One is WTS of X, another one is RTS of X. So what do you mean by WTS? W means write, TS means timestamp. RTS read, timestamp. Okay. So WTS of X means the latest time when the data item has been returned into. And what do you mean by RTS? The latest time when the data item X has been read from. Okay, so the timestamp ordering protocol, it ensures that any pair of conflicting read-write operation can be executed in their respective timestamp order only. Okay, so see here in timestamp ordering protocol, even it is possible they can ask some numerical also. Okay, I'll explain this with one numerical. Okay, so these are two rules. This will be executed when we perform read operation. This will be executed when you want to perform write operation. So let us take one example. Suppose this is one question which is having transaction T1, one more transaction T2, one more transaction T3. The value for T1 transaction which they have given is 100, for T2 for example 200, and for T3 for example 300 value they have given. Okay. Then T1 is performing read operation. Then after that T2 is performing read operation on B variable. After that, for example, T1 is performing some write operation. After that, suppose T3 is performing some read operation. Then T1 is performing some read operation on C variable. And then, for example, write of B. Okay, so these are some operation. transaction T1, T2 and T3 is performing. Now in this question, they want you to check whether rollback will occur, or if rollback will not occur after performing this all operation, what will be the value of RTS of B? Like that they can ask the question. So for that, I'll generate one table over here. A, B, C. This is your RTS and this is your WTS. Okay. Now initial value of RTS and WTS are 0. Sorry. Value of RTS and WTS are 0. Now see, first which operation, who perform first operation? Transaction T1, that is read of A. So for read operation it will go there. Now check if WTS of X, what's the value of WTS of X? X means, what do you mean by X? X means whichever variable we want, okay? So here WTS of X. So WTS of X means right now we want to perform with which data item? A. So that means we'll check everything for A. So WTS of A, what is the value of WTS of A? 0. So is 0 is greater than timestamp of T 100. Right now this is in which, this one transaction T1. So we'll execute this one only, okay? So we'll consider this one. So here 100. So is 0 is greater than 100? No. Then it will go to else part. That means execute R of X operation. Now see, set RTS of X is equals to max, okay? So now what will be the value of RTS of X? That means RTS of A, maximum of RTS of X, that means here the value is 0, and that timestamp of T. Timestamp of T value is what? 100. So which value is greater? 100 is greater, okay? So that means the value of RTS of A will become 100 now. Okay. Now next is RTS of B. So RTS of B you try to execute. Okay. RTS of B is also same. Like it will check read operation WTS. So here initial value of WTS of B is 0. Then it will compare. Okay. So WTS value is less than. So it will go to else part. And here also maximum of 0 and 200. So 200, right? So here what happened? This value will change to 200. Okay, then similarly next is what? W of C. W of C, that means now they want to perform write operation. So it will go here for write operation. Here they will compare if RTS of X. Okay, RTS of X means right now we are performing for data item C. So RTS of C, what's the value of RTS of C? 0. Okay, so is 0 greater than timestamp of this? No, timestamp value is 300. So it is not greater. It will go to else if part. Now WTS of X value, WTS of C value, is it greater than timestamp? No. WTS of C value is also 0. So this is also not greater. Okay. Then it will go to else part. Execute write operation. So in that case, set WTS of X is equals to timestamp of T. So WTS of X value, that means WTS of C value will become, what is the timestamp value? 300. So here it will change to 300. Our next operation is R of B. Okay, that is in transaction T3. Now here check R of B. That means it will go to the first one for read operation. WTS of X. X means here which variable we are talking about? B. So WTS of B. What's the value of WTS of B? WTS of B value is 200. So is 200 greater than 300? No. Then it will go to else part. Execute read of X. Read of X means read of B you execute. Okay. Then set RTS of B. RTS of B value, that is maximum of RTS of A. Sorry, RTS of A. We are talking about B. So RTS of B. What is the value of RTS of B? 200. So maximum of 200 and timestamp. Timestamp value is 300. So which is maximum? 300. So this 200 will replace with 300 now. Our next operation is R of C. Okay, now what is R of C? R of C, that means read operation. So WTS of C. What's the value of WTS of C? WTS of C value is 0. So is 0 greater than timestamp value, that is T1. So 100. So is 0 greater than 100? No, it is not greater than. Then what it will do? It will go in else part. That means execute R of X operation. Okay. Now here, as we are executing this one, set RTS of X. RTS of X means RTS of C. Set RTS of C value is equals to max of RTS. What is the value of RTS of C? 0. Max of 0, comma, timestamp of T. So R of C is in which transaction? T1. So 100. Okay. So maximum will be assigned to RTS of C. So the value of RTS of C will change to 100. Okay. Then the next operation is W of B. That means write of B. Please concentrate here. Write of B. Now here see, if RTS of X. RTS of X means RTS of B. RTS of B value is 300. So is 300 greater than timestamp of t? Timestamp of t for this is 200. So is it greater than 200? Yes, it is greater than 200. Then it will roll back. So here what will happen, here rollback will occur. So that was the question, that whether any of this operation rollback will occur. So yes, the correct answer is in transaction T2, right of B operation rollback will occur. So I hope this question is clear. It's very important for your exam. Next, now let us solve some previous year gate question on this topic, two-phase locking protocol as well as your timestamp ordering protocol. Okay. So now see, this is your gate CSE 2024 question. Which of the following statement about the two-phase locking protocol are true? Now see first option. Option first says that 2PL permits only serializable schedule. So we already know, even I explained you, two-phase locking protocol that ensures conflict serialization. So that means option A is true in that case. Then second point says that with 2PL, a transaction always lock the data item being read or written just before every operation, and always release the log just after the operation. Okay, so this is not correct. Why? Because I already said you 2PL means it's always having two phase. One is your growing phase, another one is your shrinking phase. Growing phase means acquiring all the logs. Shrinking phase means releasing all the logs, right? So here it is not possible. That means once we'll release, then again we can log. So that is not in two phase. So option B is not correct. Next one, with 2PL, once the lock is released on any data item, inside the transaction, no more logs on any data item are obtained inside the transaction. That is what the 2PL is. That's what I explained to you. Once if you unlock any data item, after you cannot lock it. Okay. So option C is also correct. Then the last one, a deadlock is possible in 2PL. That's what I said. That means 2PL ensures serializability, but deadlock can occur in 2PL. So option D is also right. The correct answer for this one is option A, C and D. Only option B is wrong. Next, this is your GATE 2016 question. Now, what is in this question? See, consider the following two-phase locking protocol. Suppose a transaction T access a certain set of objects O1 to OK. This is done in the following manner. That means they already said that it is a two-phase locking protocol. Okay. So, first of all, before we'll read further, you should remember that what is two-phase locking protocol? Two-phase locking protocol, that means it ensures serializability, but deadlock can occur. That we know. Okay, but here I think that is what some updated. So we'll see what is this new 2PL they are talking about. So step T1, T acquires exclusive log to O1 to OK in increasing order of their address. Step 2, the required operations are performed and all logs are released. So now here you can say that they are forming here the serializability concept. Okay, so what they are doing over here? Here they are forming basically the serializability concept. Correct, because now if you see in step 1 what they are telling, in step 1 they have applied the exclusive log are acquired on O1, O2, O3 in increasing order they are telling. Since as it is mentioned exclusive log, that means only one transaction can lock the object. Correct. So due to acquiring log based on ordering of this address, and logs aren't released until the transaction completes its operation. So we can prevent this circular wait in this condition that can occur in 2PL. But as they are telling this 3 step, so in this step circular wait will not occur. So as circular wait will not occur, that means there will be no deadlock. No deadlock in this case. Okay, so let us see the option. Option A says that it guarantees serializability and deadlock freedom. Yes. Okay, two-phase locking protocol. Now here what happened? A student mostly they'll say, okay, two-phase locking protocol. No, the correct answer is it can guarantee serializability but no deadlock. They'll say option C is right. But no, read the question properly. Okay, they are telling that 2PL they are executing in such manner. That means it is the, you can say updated 2PL. Okay, so in that case, in this case, deadlock will not occur because there will be no circular wait. Understood? So read the question properly and then you should answer. So the correct answer for this question is option A. Next, this is your UGC net 2022 question. Statement 1 says that, consider the following statement. Statement 1 says that conservative 2PL is deadlock free. Okay, that is already, it's written in my notes only. That conservative 2PL that ensures serializability as well as it is deadlock free. Deadlock can occur in rigorous and strict, but conservative 2PL is deadlock free. Why it is deadlock free? Because it will acquire all the lock in the beginning only. Right? That is what the advantage it's having. Okay. So statement 1 is true. Now let us talk about statement 2. Statement 2 says that Thom's right rule that enforce conflict serializability. Okay. So before I'll move further, first I'll explain you what do you mean by this Thomas Wright rule. Correct? Then only you can understand it better. So see, Thomas Wright rule basically, it is a concurrency control mechanism that is used in database that modify the basic timestamp ordering protocol. So that means you can say that it is used to improve concurrency by allowing certain write operation to be ignored. Okay, so like as I said, you confliction and all, but if you apply Thomas Wright rule, then some of write operation are not allowed. Okay, I'll give you one example so you'll understand this more better. For example, if I say transaction T1, okay, and this is my transaction T2. Okay, so now here suppose transaction T2 has performed read operation, then transaction T1 is performing some write operation on the same data item, and after some time transaction T2 is writing on that. Okay, so you think this should be allowed? No. Here T1 to T2. Okay, here T1 to T2 is not allowed. Why? Because according to Thomas Wright rule. Why? Because you simply think, okay, transaction T2 has read the value of A. Now transaction T2, okay, is read the value of A. Then transaction T1 is updating, but T2 will again not read the value, right? So transaction T1 is still writing. Understood? So this lost is update. This whatever they have written, that will be update lost, you can say. Okay, whatever updation they have done here, that will be lost, right? So because of that, this is not allowed in Thomas Wright rule. Okay, the next one, the third one says that timestamp ordering protocol ensures serializability based on the order of timestamp, right? So here in this one, so timestamp ordering protocol, I already explained you that it ensures the serializability, okay, based on the order of transaction. So here statement 3 is also right, even statement 2 is also true, because Thomas Wright rule that enforce conflict serializability. Correct. So here all the three statements are true. Now let us see the option. Statement 1, statement 2 is true, 3 is false. Statement 1, 2, 1 and 2 is true, no, false, no. So the correct answer for this question is option D. Statement 1 is true, 2 is also true, and statement 3 is also true. Okay. Let us move to next question. This is your GATE CSE question. Which one of the following concurrency protocol ensures both conflict serialization and freedom from deadlock? So I already explained you two-phase locking protocol. It will ensure serializability but not freedom from deadlock. Deadlock can occur in 2PL. Okay, so the correct answer for this question is timestamp ordering protocol. Timestamp ordering protocol that is free from deadlock and even conflict serializability is also ensured. So the correct answer is option B. Only second statement is right. Okay, next. Now this is one numerical question. Assume basic timestamp ordering protocol and that time starts from 1. Each operation that takes unit amount of time and start of the transaction Ti is denoted by Si. The table of timestamp is given below. Now here you see. So see, first of all we'll write here S1, okay. So the start of transaction S1 is at timestamp 1. Start of transaction S2 is at timestamp 3. And start of transaction S3 is at timestamp 7. Okay. Now what they want to find? They want to find RTS of A. Okay. RTS of A at the end, when it ended. So see RTS of A. Where is R of A? There is only one R of A operation. Okay. So when it started, S1. Okay, so that means it's ended at only S1, right? So here, what's the answer for this one? RTS of A, I'll write it here. RTS of A value is 1 because it is under time, this one, transaction S1. Sorry. Next, next, next WTS of A. Now see WTS of A. So where is written WTS of A? Yes, WTS of A. W of A. It is executed in transaction T2, but you can see again it is repeated in S3 also. Okay. So what is the starting time of S3? 7. So WTS of end is 7. Not, don't think it is 3. Why? Because again it is executed. Okay. And they are talking about at the end. Right. The next check for WTS of B. Check for WTS of B. Where is WTS of B? Here, and again it executed in this one, right? WTS of B. If you see here, so see, first of all, W of B, it's in S2. Okay, then after that, W of B here also. Okay, so here you see what is the, for S3, S3 is 7. So here also it will be 7. Okay, correct. So WTS of B is also 7. Next, RTS of B. So let us check for RTS of B. RTS of B, 1 in S2. Okay, then it's not repeated again. Okay, so when RTS of B is executed, S2, that means 3. Okay, now as per the sequence RTS of A, the answer is 1. WTS of A, it is 7. RTS of B, it is 3. And WTS of B, that is 7. So 1737. Let us match. Yes, the correct answer is option D for this question. Okay, next one. Next, this is your GATE CS 2017 question. In a database system, a unique timestamp are assigned to each transaction using Lamport logical clock. So let TS of TI, that means timestamp of TI and timestamp of T2 be the timestamp of transaction T1 and T2 respectively. Beside, T1 hold a lock on the resource R and T2 has requested a conflicting lock on same resource R. So the following algorithm is used to prevent deadlock in the database system, ensuring that a killed transaction is restarted with the same timestamp. Okay. So now here what they are telling, as we know that unique timestamp are assigned to each transaction. Okay. Using this Lamport logical clock. Okay. Now here, see what they said. Now here first is timestamp of T2. If it is less than timestamp of T1, then T1 is killed. Otherwise, T2 is wait. So here, first we'll check that if it is would wait scheme. Okay, I think that is only will be applicable over here. So here, this logic comes under basically would and wait scheme because it is given that T1 holds a lock on the resource R and T2 has requested a lock on the same resource R. Correct? T2 has requested on the same resource R, and when T2 requests T1 is killed, here you can say T1 is killed because timestamp of T1 is larger than T2. That means that T1 is new transaction. Okay, so now that is would and wait that avoid this one star vision. We'll check here. Now see, here as the new transaction will die. What they said, T1 is killed. Okay, so now and T2 should wait. Okay, so as if a new transaction dies and restart with the same timestamp, the older one that survives. So after older transaction, new will definitely execute. Correct. So that means there is no possibility of starvation over here. That's what the question is, right? See, assume a transaction that is not killed terminates eventually. Which of the following is true about the database system that uses the above algorithm to prevent deadlock? So here what they want to ask you about whether it is deadlock free or whether a starvation can occur or no. Okay, so here as they are using this would and wait scheme, that means you can say that no starvation will occur in this case. No starvation will occur in this case. And If there is no starvation, that means it is no deadlock also. Okay, so there will be no deadlock and no starvation will occur. So now let us match the option. The database system is deadlock free and but no starvation occurs. So here even deadlock will not occur and no starvation. So the correct answer for this question is option B. I hope it's clear. So this is all about the topic log-based protocol. This one 2PL I have covered, timestamp ordering I have covered. This is very important. Actually, little bit complicated. I've tried to make it easy. So please try to solve this all question. Any doubt, any question, you can ask it in comment. And if you like my video, please like and subscribe my channel. Thank you.